Okay, welcome to this video where we're having a look at 9D.2, 9D3, 9E, and we will have a quick look at 9F as well. So firstly with 9D2 we're continuing on with confidence intervals, and what we're saying is how big do we need to make a sample if we want to guarantee a certain width. Now the width of the confidence interval is just the top end of the confidence interval, take away the lower end of the confidence interval. So in the example of height, this was our confidence interval here, and so the width would be 180.47, take away 175.52. That would be the width of our confidence interval. It's the range over which we're making the confidence interval claim. So if we have a look at 9D.2, we're continuing with that same example with height, and they're saying rather than having a width of 6 or 5 centimetres here, how many students would we need to sample if we want to make a 95% confidence interval with a width of 2 centimetres? And so that's just this formula here that we're crunching. Okay, 2 times 1.96 times the standard deviation on the width. So I've crunched that there, and we're always going to round this number up in order to guarantee that level of confidence. So even if that was 245.1, you would round it up to 246 students in order to guarantee that level of confidence. The other thing to note is this number here, the 1.96, can change depending on if you want a different level of confidence. At the moment, we're just mostly dealing with 95% confidence, but as we've seen, there are other values of Z alpha on 2 that give us different levels of confidence. So if we wanted a 99% confidence interval, we were doing an N calculation for that. We'd put the value 2.58 in there instead of 1.96. That's the only difference. So that's 9D.2. Okay, if we have a look at 9D.3, we've got this interval, confidence interval we started with in 9D1 about height. You know, we're 95% confident that the true mean height of Year 12s is somewhere in this region. Jimmy claims the true mean height could be as high as 182 centimetres. Is his claim correct? The answer is no, because his claim is outside our confidence. Alex, on the other hand, claims that the height could be as low as 176. Is her claim correct? The answer is yes, because it lies within the confidence interval, so there is enough evidence to suggest that Alex's claim is correct, while Jimmy's is wrong. So that's basically all you're doing in 9D3, is you're finding confidence intervals and then testing them with regards to some claims. So 9D is all to do with normal distribution. When we move on to 9E, we completely stop normal distribution and we're just talking about sample proportions. And so probably it's best to just leap into the example of this, and then you see how these notes tie in with it. We have a sample of 10 people, finds 3 of them have blue eyes. State the observed value of P. So that's just 3 out of 10. Or 0.3. Find the mean and standard deviation of P. Well, in our notes above we have the mean of P is just P, which is 0.3. But the standard deviation is the square root of P. And P times 1 take P, they've written it as here. We like to call that P times Q, where Q is just the inverse of P. We remember back to binomial distributions when there's an event that's either a success or a failure, and in this circumstance either you have blue eyes or you don't. So we've got the probability of having blue eyes, 0.3, times the probability of not having blue eyes, 0.7, divided by the number of samples and the square root of that. And so we've got the standard deviation is 0.145. So we've got the mean and standard deviation of it. Is P normally distributed? Now, P is normally distributed if it satisfies this condition. N times P is greater than or equal to 5, and N times Q is greater than or equal to 5. Let's have a look here. N times Q is 10 times 0.7, which is 7, so that's greater than 5. We've satisfied the first condition. Let's check if N times P 10 times 0.3, that's 3. It's less than 5, so no, this is not normally distributed. Clearly, if we increase the number of samples, it would become approximately normally distributed. Okay, once this number is greater than 5, then we can say that it's normally distributed. But it has to satisfy both of those, NQ and NP. And if it's normally distributed, we can do some normal calculations with it, which I think it gets you to do in the exercise, but that's a good introduction to it. Then if we just look at 9F, basically the rest of this chapter is just pretty straightforward. We're basically applying the same methods we've learnt for sample proportions that we did with normal distribution. So we're going to have confidence intervals, we're going to have finding a sample size, and then testing a claim about it. And the confidence interval for a proportion is just this formula that we've got here, where P hat is your observed value of the sample proportion. And again, you've got the square root of P times Q on N, you know, your standard deviation there. And again, your 1.96 is just representative of the 95% confidence interval, and you can be asked other levels of confidence, for which we're very familiar with now anyway. So I'm not going to go through this one explicitly, but the sample proportion is just going to be 55 out of 100, or 0.55. And from that we can construct the 95% confidence interval just by crunching it in the formula. You will find, you can put that in your calculator as well. It's got the exact same instructions as here. Okay, you're pressing these buttons, but rather than pressing first sample, you press first proportion. And that'll bring up all the information you need just to crunch it in your calculator, confidence interval for a proportion. I think that's enough for now. Good luck with it.